Hi everyone. Um, this video is not really going to be any sort of new theory, I guess. It's more just a like a working through problems kind of video. The relevant section in your textbook doesn't introduce any new theory. It just gives you a way to solve a few different kinds of problems using function notation, okay, or this idea about functions in general. So we'll just work through some questions. There's 4 questions here. Hopefully the video doesn't drag on for too long. If at any point you feel like you need to pause or attempt the questions yourself, go for it. But it will be probably kind of long. We'll see how we go. All right, so question 1 says find a and b for f of x equals ax plus b if f of 1 equals 5 and f of 3 equals 9. Okay, so it's basically asking find out the values of a and b to make it so that the function spits out these values when we put in the x values of 1 and 3. All right, so according to this, it's saying that f of 1 equals 5. So that means if I have f of 1, what that means I have to do is replace the x with the 1 for our function definition. Okay, so replacing the x with a 1 will give us that. Okay, and we know that that's going to be equal to 5. Okay, so if I want to clean it up a bit, I can just write it as a plus b equals 5. Cool. All right, we can do the same thing for f of 3 equals 9. So underneath, I'll write that, f of 3. That just means to replace the x with the 3. And we'll get a times 3 plus b. And we know that that's going to be equal to 9. Cleaning it up a bit, that gives us 3a, 3a plus b equals 9. So we've got 2 equations and 2 unknown values. So can you think of what we might be able to do in this situation? If you said simultaneous equation, you'd be correct. So simultaneous equations, I think it's easier to do it using the elimination method. So I'll subtract equation number 1 from equation number 2. So I'll do 3a plus b equals 9 minus a plus b equals 5. 3a minus a is just 2a. b minus b is 0. And 9 minus 5 is 4. And that tells us that a is 2. Cool. All right, so to work out b, we just take this value of a, substitute it into one of the original equations. I think it's easier to do it in the first one. So you basically get 2 plus b equals 5, and then you get b equals to 3. There you go. Done. Okay, that's a very common type of question. Working out specific values of your coefficients or your terms in your function based on information, such as some coordinates. Basically, these are coordinates. Okay, what the question is saying is that the function goes through the point 1, 5 and the point 3, 9. Okay, you could work it out the other way. Another way, what you could do is you could work out basically the gradient from these 2 points. Okay, you could work it out and get 9 minus 5 over 3 minus 1. 9 minus 5 is 4. 3 minus 1 is 2. 2. Okay, and that 2 here corresponds to the coefficient of x, which is the gradient. All right, so you've got the gradient. Now you've just got to work out b. And what you could do is you could just take one of the points, substitute it into y minus y1 equals m times x minus x1. So we'll do the first point, y minus y1 equals m times x minus x1. Y minus 5 equals 2x minus 2. Y equals 2x plus 3. And again, you see here that 3 corresponding to b, which is that plus b in our function. Okay, so there's a couple of ways to do it. Here we're just using function notation, substituting the values of our function into function notation and working out a and b using simultaneous equations. Okay, there's a couple of ways to do it. All right, question 2. So it says find a linear function g such that g of 0 equals negative 3 and whose graph is parallel to that of the function f of x equals 2x plus 5. All right, so it's asking us to find a linear function g. What rule does a linear function have? Well, a linear function is completely defined by a gradient of some kind, mx, as well as a y-intercept. Okay, so basically our job here is to work out m and a c, almost kind of like what we did in this question. It's just that we have a different kind of information. All right, so we've got this first bit of information here, g of 0 equals -3. So what we could do is substitute 0 into our function and see what we get. So g of 0 equals m times 0 plus c. M times 0 is just 0, so all we're left over with is c, and we know that when we substitute 0 in, it gives us -3. And so we end up getting our value for c given to us straight away. Okay, if you're paying attention, you'll notice that this is just the y-intercept. Okay, because we're substituting an x value of 0. When you do that, that corresponds to the y-axis, and hence you'll get your y-intercept. All right, so we've got c. How do we find m? Well, that comes from the second piece of information. It says that the graph is parallel to that of the function f of x equals 2x plus 5. So if two linear graphs are parallel to each other, that means something is the same. What's the same? If you said gradient, that's correct. Cool. So we know that the gradient of this g function has to have the same gradient as this f function, and the gradient of the f function is 2. So we know straight away that m is 2. And therefore you can just write out your g function in full. We know that's going to have the rule 2x minus 3. All right. So you can see, again, we're starting our question based on the fact that we know our rule has to look like something, okay? In particular, mx plus c, or if you prefer, ax plus b, like in the previous question. And then you're just using your information bit by bit to sort of coax out the values of m and c. All right. Question 3. So find the quadratic function f such that f of -2 is equal to f of 4, which is equal to 0. Okay, so f of -2 is equal to 0, and f of 4 is equal to 0. And the greatest value of f of x is 18. All right, so how do we start something like this off? Well, it's asking us to find a quadratic function. Okay, so let's just try and think about what this information is telling us before we start writing out any equations. Okay, f of -2 equals 0. What that says is when x is -2, y is 0. And if you think about it, that corresponds to an x-intercept. It's saying that when x is -2, y is 0. That's that point there. The other one's saying when x is 4, y is 0, and that corresponds to a point over here. Okay, so these are just giving us our x-intercepts, so we know what the x-intercepts are. All right. Now, if you know the x-intercepts already, that means you can write the rule of your quadratic function to be this. This is now going back all the way to quadratics. Okay, we can write our rule like that, where x1 and x2 are the values of your intercepts, and a is the coefficient of x squared. Okay, so we know what the x-intercepts are. We can now fill in that information in our rule, and I can write it as x plus 2 times x minus 4. All right. We just need to now work out what a is. Okay, and that comes from this information here, where it says the greatest value of f of x is 18. So that's a weird phrase, the greatest value of f of x. What does that mean? Well, it means the largest value of y. Okay, the largest possible value of y. Now, there's only two ways that can happen for there to be a largest value. Okay, either your quadratic has endpoints, so it might look like what? How do I undo? I don't think I can undo. Sorry. Okay, so either your quadratic has endpoints, so it might look like that, and have an endpoint here, and the greatest value is 18, okay, that could be one possibility. But in order for that to happen, your domain would have to be restricted. And it's got no information in the question about our domain being restricted. So I don't think it's going to be that. The only other way that it could happen is if it was inverted and it had a turning point somewhere up here. Okay, and the value of that turning point was 18. Okay, so that seems to be the most likely scenario. So basically we just need to work out the coordinates of that turning point. And that will allow us to input an x value into here, make this equal to 18, and then allow us to solve for a. So the question is, what is this x value? Okay, well, you should know based on the symmetry of a parabola that your turning point is always going to be exactly halfway between your x-intercepts. Okay, so now we've got the x-intercepts, -2 and 4. What is exactly halfway between that? Well, that's just the average of the two. So you go -2 plus 4 over 2, and you end up getting 1. Okay, so that is 1. So our coordinates are 1 and 18. All right, lovely. So now I've got a third piece of information that I can use by substituting into my function to solve for a. So that means when I have f of 1, I get a times 1 plus 2 times 1 minus 4. Okay, what does that turn into? Well, 1 plus 2 is 3. 1 minus 4 is -3. So I have a times 3 times -3, get -9a. And I know that when I substitute 1 into my function, I get a y value of 18. So I know that equals 18. And we can solve for a now. 18 divided by -9 is -2. Cool. So I know that my rule, if I write it out in full, let's use another color, that it will be f of x equals -2 times x plus 2, x minus 4. Okay, and you can expand that out if you like, but that's a perfectly valid form of a rule for a quadratic. Okay, one more question. Question 4, so find the set of values k for which f of x equals 3x squared minus 5x minus k is greater than 1 for all real numbers x. Whoa, okay, so what does that mean? Find the set of values of k for which this function here is greater than 1 for all real numbers x. Okay, I'm going to switch to Desmos and show you what's going on with this question. So let's switch out. Okay, so we have the rule y equals 3x squared minus 5x minus k. Add a slider for k. Right now k is 1. Okay, now the actual question is saying find the set of values of k for which this function is greater than 1 for all real numbers x. So that's basically saying what value of k is necessary so that this graph is always above a y value of 1. Or if you prefer, y equals 1, like that. So if I play around with this slider, okay, notice if I make k larger, the graph shifts down. If I make k smaller or more negative, the graph shifts up. And you'll notice there's a point just there, okay, somewhere between, if I zoom in, somewhere between k equals -3 and k equals -3.1, there's a point in between, some value of k, that my graph makes it so that it's always going to be above this line, okay? So the value of k for which these two graphs intersect is somewhere in between -3 and -3.1. So how do we go about answering this question? Find the set of values of k for which this function is greater than 1 for all real numbers x. Okay, so we could go and use the approach, figure out what value of k makes them intersect, and then just write your answer as k has to be less than that number. Okay, now how do you find out where two graphs intersect? Well, you make the equations equal to each other. So let's do that. let's say we've got 3x squared minus 5x minus k equals 1. Okay, this is the graph of 3x squared minus 5x minus k intersecting with the graph of y equals 1. Okay, all right. What we can do here is rearrange it so that we've got 0 on one side. We'll get 3x squared minus 5x minus k minus 1 equals 0. Okay, so what we end up with is basically a quadratic equation. Okay, and if we could solve this quadratic equation, actually that's not going to work, because what we'll be doing is solving for x. We don't want to solve for x, we want to solve for k. All right, so basically we've set it up so that we've got two graphs intersecting with each other, but we want to know the value of k so that the graphs never intersect. Okay, the only way that that could happen is if this parabola was always above this line y equals 1. Now remember, two graphs will intersect when, if we make their equations equal to each other, and the resulting equation is a quadratic, the discriminant of that resulting quadratic equation would be less than 0. Okay. Discriminant. So let's say, what is the discriminant here? B squared minus 4ac. What's b? Negative 5. So negative 5 squared minus 4 times a, which is 3, times c, which is negative k minus 1. Okay, and I want my discriminant to be less than 0 because I don't want these two graphs to intersect. And basically our job is to find out the value of k that makes this happen. Okay, so let's sort this out. Negative 5 squared is 25 minus, okay, so we've got, actually before I write minus, let's see, we've got negative 4 times 3 times negative k. Well, that's positive 12k. Okay, negative 4 times 3 is negative 12. Negative 12 times negative k is positive 12k. Do the same thing for negative 1 in here. So negative 4 times 3 is negative 12. Negative 12 times negative 1 is positive 12. And all of that has to be less than 0. All right, cleaning it up. So 25 plus 12 is 37. Plus 12k, less than 0. Here we can subtract 37 across to the other side. And we get 12k is less than negative 37. And finally, k is less than negative 37 over 12. Okay, which if you were to work out, it'd be something just less than negative 3, which corresponds to that value that we saw on Desmos. Okay, so there's that value here. If I actually make y equals negative 37 on 12, okay, negative 3.0833333. All right, and that corresponds to that value of k. That would make those two graphs intersect each other, and we want our value of k to be such that they don't intersect. So k has to be less than that value. All right. So that was a bit of a tricky one. Okay, that's sort of like the top level that you'll be getting of these kinds of questions. So go back and review it. Make sure you understand where all these steps came from. All right. Again, apologies for the length of the video, but there's no new stuff in here. It's just working through problems. All right, I will see you next time.